All right, welcome back. We're going to continue with section 7.3 and we're going to finish up the second half of using percents to solve our word problems. All right, let's continue here. Let's say only 24% of the registered voters participated in the last election. How many of the 33,000 registered voters did not cast a vote? So here, our question is first you start with the question to define your variable. It's asking us how many of the 33,000 registered voters did not cast a vote. Now, here it already says 24% registered voters participated. So that means how many did not participate? So N equals the number of non-voters. And because 24% participated, when you subtract 100 minus 24%, that's going to give us 76%. And then you convert 76% into a decimal, so you get 0.76. Now, the number of non-voters, that's the part, and that is equal to our percent times the whole. So the percent, 0.76, times the whole, the total number of registered voters is 33,000 registered voters. So that's why we have that 33,000 here. When you multiply this out, you should end up with 25,080. This would be the number of registered voters who did not cast a vote. 25,080 did not vote. Our next example, we have 2,256 in attendance, left 6% of the seats in the auditorium vacant. Determine the seating capacity of the auditorium. So, if we have 2,256 people who are sitting in the audience and only 6% of the seats were left empty, we need to find out how many, what is the seating capacity in the auditorium? So let's say S is equal to the number of seats. That's the whole. Okay, that's the total number of seats that are available in the auditorium. That would be our whole. So 6% of the seats were empty. So that means what percent of the seats were filled? So 100 minus 6% gives us 94%. And then when you convert that into a decimal, you move your decimal over 0.94. Okay, and then this is your percent times the whole is equal to the part. Okay, and 2,256, that's the part, because that's the number of people who showed up. But the total number of seats in the auditorium is your S, or the whole. So we have 94% of the whole, okay, 0.94 times S, is equal to the part, and that's 2,256. So in order to solve for S, we have to divide by 0.94, and then your S, 2,256 divided by 0.94, and that is equal to 2,400. So going back to the question here, there are 2,400 seats in the auditorium. That's your whole, and 2,256 was just the part of it. The next example here, we have the cost of a large beverage is 40% more than the cost of a small beverage. Determine the price of the large drink if the small costs 95 cents. So, first we have to look at the question. Determine means you have to solve or find out. Determine the price of the large drink. So the small costs 95 cents and the cost of the large is 40% more than the price of the small. So let L equal the cost of the large beverage. So the large beverage is L. Okay, the small beverage costs 95 cents. But the percent is 40% more, so that means it's 100 plus 40%. 100% plus 40%. That's the 40% more. And then times the cost of the small drink, because that's your part, not 0.95. Now you multiply that, and when you multiply it, you get $1.33 for the cost of the large drink. So the large beverage costs $1.33. Now, just to recap here, okay? The cost of the large beverage is what we need to find. The large beverage is 100% plus 40% because it's 40% more than the cost of the small beverage. So 1.4, that's 140%, or 1.4 times the cost of the small drink, 0.95, and then that gives us $1.33 for the large beverage. All right, let's take a look here. The box says use 3 ounces of a powdered drink mix and add enough water to make 16 ounces. How much water is used? What percent of the drink is water? Okay, now let's take a look here. We've got several things we need to look at. How much water is used? So, the